Champions, we've got a custom Hiwatt 50 here, SA112. Came in with reports of blowing fuses. So we went over the whole thing. I just want to go over everything that I found in it. So the initial fault was a short from one of the plates to ground. And it wasn't in the valve, it was the flyback diodes. Now these don't look stock. Couldn't find them on any schematic floating around, but maybe other people that see more of these things than I do can shed some light. This is a string of diodes, two diodes in series, one N4004. They're a 400 volt 1 amp diode. Not really suited to this, they're just a general purpose diode. They should be using a fast recovery diode in that situation, and it should be rated at like 3000 volts peak inverse. So that went short circuit. There was just blowing fuses, and when you put it on the variac at low voltage, it was just nothing but hum coming through the transformer, and that was the ripple that was remaining on the plate supply coupling to the speaker. So going over the whole thing, I repaired that fault, and then I went through and started sort of just checking the rest of the amp out, and there's a bit of weirdness going on. Very microphonic, like just touching it. I thought it was one of the preamp valves, so I was subbing them out, but it seemed that no matter which one I changed out, even though you tap on the valve and it was really popping and clicking and hiss and scratchiness and just everything, hum, I couldn't isolate it to one valve, so I was swapping them out one at a time. One seemed to affect it, then I put it back in or put a new one in its place, and it was still doing it, and it was still super sensitive. When an amp is really microphonic, you touch it almost anywhere, and it just seems like that's the fault, right? So I was poking around, and then I found down in the back here on the input jacks is a ground wire, and it was never soldered from the factory, so it was just floating around, sometimes making contact with the chassis, sometimes not. So volume was jumping around, all sorts of weird stuff. So I fixed that, and then we found that there was scratchiness in the pots. Not dramatic, just like a slight when you move any of the volume pots. So that became the next target, and what I found was this board is leaking. So it seemed like almost every stage had leakage, and that didn't sound right. They're V-shaped caps, they're pretty high quality caps, and I thought maybe whatever triggered the flyback diode to die could have maybe damaged the caps, but it just didn't seem right. It was everywhere. So then I noticed this little unused turret down here. See that little bugger there? So that had about 3.5 volts on it, and it's not connected to anything, it's just pressed into the board and that's it. So that whole board itself is leaking. Now I know the brown boards have vintage cred and they look cool, and when you look at a gut shot everyone busts a nut over them, but basically for turret boards, if it's not fiberglass, it's no good. If it's brown, kick it down. I don't know. Basically the board's leaking, and it is exacerbated by temperature, so as the thing heats up it leaks more. The one at the back has the bias supply. We're kind of helped in that respect because it's linear. There's not a lot of high voltage leaking into the bias network post divider, so the bias is stable, which is good. But what it's doing is throwing the bias off in the preamp stages and making the pot scratchy. So we might give it a bit of a clean in the hope that maybe it's surface contamination. We might heat it up a bit more in hope that maybe there's some moisture. This thing was kept in a warehouse for 5 years without being switched on, so maybe we might be able to drive some moisture out of that board and hope for the best. But if it doesn't help us at all, well, basically the only solution is to replace it with a fiberglass turret and redo the whole thing. So yeah, not ideal. Now this is like a $4,000 amp, and there's just stuff on it that is inexcusable at that price point. And it's not a little boutique builder that doesn't know any better but just chuck some ridiculous price tag on their amps either. This is Hiwatt, you know, they've been around since the Who, before the Who, and they've got that legacy. And you just got tack solder joints, you got look, I'm suspecting that someone's been in this before, because there's stuff that just doesn't make sense for it to be Hiwatt. You've got snap-in caps, two of them there in series, 220 microfarad, 220 oofs, 350 volt. The wires are just stuck to them and soldered. Like this one here, it literally is just touching it, and just they could have wrapped it around it, but not. It's just got a blob of solder on there, and it's just sitting next to it. So that's not ideal. There's a lack of balancing resistors, so that means the voltage could be uneven on the two caps. That's not good either, and not only that, but it doesn't discharge itself. This amp, you can turn it off. I did that earlier today. I turned it off, and 4 hours later, still had 390 odd volts. So that's not good either. Another thing happening, you can see up there, that's the impedance selector switch. That was intermittent, took a few goes of flicking it back and forth. That is probably what caused the flyback diode to blow, even though it's a pretty borderline rated diode. I'm guessing maybe running it without a load, because the impedance selector switch playing up is probably what caused the flyback event in the first place. So I might replace that, maybe give it a clean, but we'll see. It feels a bit sketchy. It's possibly just surface corrosion, but we'll see how that cleans up and replace it if necessary. And then we'll go over the whole thing, and hopefully we can sort this board issue out. So, quick costume change. It's tomorrow now. That's how it works around here. Customers flood in and you don't have a chance to look at anything. So we'll just have a look at some other things I noticed hardware wise. So we've got this heat shield here, which is kind of buckled, and the fixing points down there, they've sort of had to bend the thing to get it around the caps. Not sure. It almost looks like it was fabricated in a bench vise just by whacking it. Not what you'd expect on a $4,000 amp. You've got Epcos caps here. These are the ones I'm not sure are original. That's a Tube Amp Doctor. That's a multi-section 50-50, 500 volts, and these are 350 220s, and a 220 400. Oh, sorry, they're all 400s. So yeah, they're in series anyway. Preamp valves, you can see there's a capped out one there, and then two capped out holes for the 100 watt version. Just a little bit of dodginess here. I know I'm getting anal, but you got to remember the caliber of this thing, or supposedly. So they've put the sockets too close to each other, so they clash. And the screws are sort of, you know, it's a bit skewed because the plates are overlapping each other, and they're not really sitting positively down as a result. And you can see they're sort of overlapping there. It's just messy. Like, just space them 5mm further apart, champions. Like, you got plenty of room here. So that's all. These chassis must be pressed that way. So every one of these must have that problem. And this is a later one. So have they not learned the lessons in the previous 20 years or whatever that they were making these things? But anyway, it all works. They're belts and sockets. They're okay. They've got the bear trap retainers. So there's your mains fuse, HT fuse, voltage selector, and impedance selector. That's the one that's playing up. So you can see on the front here, it's almost like a pickguard material for a guitar. And what they do is they sandwich it together. Oh, it almost looks like what binding is made out of. Like, they lay the sheet stock and then they rip it into tiny little strips, and that's your binding that you use for around the edge of guitar bodies. And it's sandwiched up and the outer layer is black, and to create the lettering they've actually routed through the black layer. So that's a very nice high contrast, long lasting way of printing a, well, not printing, it's subtractive machining of creating all your markings on the front panel. That's never going to wear away. They do collect with a bit of schmoo over time, but you just give it a clean and it should be like new again. It's not the cheapest way of doing it, and you are limited to certain fonts. Here they've opted for a single pass, which is actually a pretty hard font to find, just single line vector graphic fonts, ones that don't have an outline, because this is just a single pass with the router bit, and the router bit gauge is one gauge here, another end mill thickness there, and then another end mill thickness here. So it looks like 3 different tools just for routing the lettering on this front panel. Now it's got decent chicken head knobs. They're brass insert metal screws, so you know that's decent. It's got Cliff jacks, which you'd expect from something in the UK, being that Cliff is in the UK. It actually has a Cliff logo in there. It's got Partridge branded transformers, both the power transformer and the output. So that's nice. We've got JJ's valves all around, 12AX7s, and then obviously the 2 EL34s, excuse me. They're all looking good, Nick. This thing's basically never been used. I'd like to give Hiwatt the benefit of the doubt and assume that maybe someone else has tried to fix this thing and it's become a bit of a problem dog because they couldn't figure it out or just didn't have the time or budget or whatever. But we're going to sort it out. We're going to make it bulletproof, and if we need to replace the turret board, we will. Originality be damned. We want the thing to be a killer for a long time. Now the first thing I did notice was there's an unused triode, and what do I think? I'm a metalhead, so what do I think as soon as I see an unused triode? I think more gain, don't I? It's tempting, but I might leave this one original considering its value. But hey, if one day I decide I'm going to keep it, I think we're going to use that triode and we're going to make it a fire breather. But in the meantime, we'll just get it purring as Hiwatt intended. So, plan of attack. I am gonna reinstall some flyback diodes, but we're gonna use the R5000Fs, fast recovery diodes. Gives them a chance to come back from the dead before they go dead short circuit, if there's a little spike. Their job is still to go to ground and blow the fuse, but their chances of recovering are higher with a smaller spike. So we've cleaned up the impedance connector. That's reliable now. Given it a few cycles, it probably had some surface corrosion from just never being changed in its whole life and sitting in a humid environment in a warehouse. We're going to install balance resistors. We're going to redo this wiring. I've got some nice new stranded Teflon coated wire. That one's sort of rubbing against the chassis too, which I don't like because that's a sharp edge. So we're going to lift that up. We're going to properly dress these leads. We're not just going to poke and pray like some people say. I like that. We're going to reuse these caps, the snap-in caps with the terminals that are meant for a circuit board, but we're going to actually wrap the leads around it. We're going to redo the grounds here because we need the extra length to do that. Install the balance resistors, 220k, I don't know, 2 watt would be adequate. We're going to clean this board first with some alcohol. We're going to rinse it thoroughly, redo that process several times with a cloth under it so shit doesn't go everywhere. See what that does to the conduction. We've got a free turret here and we were monitoring about 3.5 volts on it once it warmed up, and when I heated up the area with a hot air gun, the voltage went up to about 7 or 8 volts, which is terrible if it's finding its way to a grid of one of the preamp stages. If that doesn't work, we'll come up with another plan, which will likely mean a new turret board, which is not the path I want to go down in terms of originality as well as work, but it's one of those rainy afternoon Sunday jobs that I'll get done because I want this thing to be reliable. This board isn't showing any issues, as previously mentioned, probably because of its stretched out nature being a single line of turrets. There's not high voltage right next to sensitive lines. It's sort of bias over here, high voltage over here, and there doesn't seem to be any drift. I've had it on standby for pretty much all of yesterday. Not on standby, in idling in play position pretty much all of yesterday as it warmed up, and there was no bias excursion at all. The bias slight change in dissipation was following the mains fluctuations, so we're good there. Just everywhere that there's a connection that I'm not happy with, and I know I'm being anal, but hey, that's me. There's just wires just poked through and then soldered, not even trimmed, not wrapped. I don't want a full wrap like the annoying ones you get in some boutique shit boxes, but I just want a half wrap just so it's mechanically sound and the solder just makes the electrical connection. Some areas where I'm not real happy with just little stuff like that might short out in the future. We'll clean that up. Some areas the soldering's great, in other areas not so great. So that's what leads me to think that someone's been chasing problems on this thing before and maybe given up. Let's hope anyway, because if that's what Hiwatt's putting out, oh lordy. Right, so the soldering iron's up and angry. Just sitting around 375-ish degrees science. We're gonna possibly clean the board first, because there's no point doing all sorts of other cleanup work if we discover that we've got to change that turret board. So let's eliminate the DC leakage first, or at least attempt to, and then go from there. Right, so I've got the thing sitting up on a precarious angle, and I've got some paper towel under it so I can run off. I'm just going to brush away at it between the components and see if we can get rid of any surface contamination, and then pray that it works, because I really don't want to replace this board. I do have the FR4 here ready to rock, and you know, I could do some layout improvements in the process, but I'd like to avoid modifying it at all. Alright, so quite a bit of crap came off the top of that board. It looked pretty clean at first glance, but when you look at what came off it, a little bit hopeful that that's made a difference now. I didn't hold much hope until I saw that. Let's dry that off with compressed air. Then we'll fire it up and see if there's any change to that voltage on that vacant turret. Right, so we're firing it up. She's just warming up. Pop the fluke where you can see it. Drawing 38 watts in standby. It's settling down to about 80 watts, which is what I measured before when I biased it, so that's good. A little bit of background hiss with everything at 12 o'clock, but nothing too dramatic. Turn the volume down so we don't deafen ourselves. If we measure some voltages, and that is very promising. So I was getting 3.5 volts there before, and now it's less than 1. Oh, it's less than 0.2. It's fluctuating. Just give it a quick listen in its current state. That's into the bright channel. That's the master volume at 12 o'clock. That's the gain maxed out. Take them to 12 o'clock. Flatten the EQ. We're into the bright channel. That's everything 12 o'clock. A little bit brittle, a little bit lacking in the low end, but of course that's the bright channel. Going to the normal. It's a lot more full. Losing a bit of that sparkle, but it is a Strat. I'd probably run like a Strat and a Telly into the normal channel, and then like something with humbuckers, a Les Paul or SG or whatever into the bright channel, and that would bring out the sparkle in a slightly darker pickup. Excuse everything rattling on the shelf. I'm yet to get in a face and do the proper miking thing and all of that one of these days, but at the moment, you put a lot of effort into YouTube and all you get is 200 views and someone telling you that they don't like the way you look, so you get what you get. So I'll crank the gain all the way up. Very moderate overdrive possible there with just medium output pickups, passive. That's all the preamp distortion she's got on tap on the normal channel. Let's have a look at the bright. About the same, just lacking a bit of low end. And then, because it's a 4 input model, the inputs below are just the same but lower gain, slightly darker. That's a bright bottom. It's a bright top. Normal bottom. Normal top. So it's got a very nice overdrive character. It's not your traditional long tail pair phase inverter, so it doesn't have the traditional sort of breakup of a Marshall or a basement. Hopefully I'm not clipping the mic too bad there. That's starting to get into a bit of output distortion there. It's got some jam. It was putting out about, I think it was about 68 watts into 8 ohms. That was at 1 kilohertz, 1 kilohertz. So yeah, it's from back in the day when amps actually put out more than they marketed, not 75% of what they marketed. Okay, so here's what I was talking about with the lack of bleeder caps. This is the main reservoir cap here. Sitting at 470 or 480-ish. We've got some mains fluctuation happening here too though. 480. Let's put it into standby. And that pops it above 500, 570, 507, sorry. And then we'll turn it off. That's the mains is turned off now, and that voltage is just sitting there, dropping ever so slowly. But that'll probably rest at around 350, 400 volts and sit there for a significant time, like several hours. That's not good, and the voltage on these two caps, 242, 493, is about equal. But if one cap was to start degrading, it would hog all the voltage. Well, it'd hog all the voltage drop, and the other one would get the remainder of the voltage and possibly go over the rating. The balance resistors discharge as well as balance the voltage equally between the two caps. As long as you're above the leakage current of the caps, 220 to 470 odd K resistor is usually adequate to balance them nicely and discharge within a couple of minutes. You don't need to discharge it in 10 seconds. Some amps do have like 100K ones. That's just a bit of a waste of energy if you ask me. 220 is a nice sweet spot, and that's what the schematic actually specs for this model, which is, it's surprising that it's not in there. It's shown on the schematic, so don't know, maybe someone replaced the caps at some point and forgot about it, or didn't know what they were, or yeah, so like 2 minutes later and we're still sitting above 450 volt. So we're powered up again. A good way to discharge most amps is just crank the thing up, turn it off the mains, leave a standby on, and then with your guitar just smash it with as much signal as you can, volume maxed out. Still going. She's down to about 12 volts. Still dropping, slowing down though. It'll get to a certain point and then just sort of stay there, probably around 10 volt. But at least now we're safe. We're not going to hurt anything, and you can just, so you can see there the voltage difference when it's dropping down 1.7 and 11 volts. So that cap's got the majority of the voltage over and that one doesn't. Of course, it's not a real case scenario sitting at 10 volts, but it just gives you an indication. If they had resistors on there, the voltage would be equal between the two of them. So yeah, we're settling it around 11 volts, so we can safely short that out to ground and take out the remainder. If you're a tech, you'd already know this, but if you've got a residual current device or an earth leakage detector fitted in your workshop or your house that you're working in, and you go to solder with a ESD safe soldering iron which has a grounded tip, and there is a ground reference, so you've left the amp plugged in, or you've got your signal still plugged in with a common ground going through the signal generator, it will detect that voltage as leakage through the iron and possibly shut your power off, which isn't the end of the world, but it's annoying. And in my case, this is a shared tenancy. The main RCD, I've got one here, but the main one is in the neighbouring tenancy. That's the landlord's factory that this is an add-on for. So if he's on site, he's a builder, I wouldn't be able to access it to restart the power, so I'd have to go to the pub instead of work for the rest of the day, and that'd just be terrible. So let's not do that. Alright, so here's the power supply schematic. I've checked and it's pretty well accurate. There's a few different part numbers, like it's got 1N5408s instead of the BYX94, but that's probably an obsolete diode. You got your bias supply as drawn, that's all accurate. You've got here showing the 220k resistors that I was talking about, and they're not present on this amp. And you've got another pair of 220s across that. That's the dual section cap there. So it's a bit of a weird setup. It's using one half of it as a filter going to one of the preamp nodes, and then the other half is part of the, I guess, the phase inverter node. You've got your HT here. Oh, sorry, no, that'd be your screen node. So that's the screen node there with 100 ohm dropper there with 1k screen grid resistors on each output valve. You got your main plate supply there, standby switch there. So your reservoirs are before the standby switch, so that's why they're staying charged when you turn the standby switch off with no balancing resistors. It shows a polarity switch, which was probably an earlier version, so you know, like the death cap thing. That isn't present on this model. It's got a IEC input and the ground goes directly to chassis. Alright, so we fully discharged the caps, went down to 0.0, like 1 millivolt, and now you can see it's recovering chemically. It's gone back up to about 3 volts, 3.5 volts. So no biggie, it's not going to hurt us. We've got no ground reference, that was just a test speaker. So let's get started. The first thing we'll do is remove this wiring that I don't like here, redo the grounds, wrap them properly, and we'll install the balance resistors. So this here is the supply side, that's the screen grid node there, and this goes to the preamp with that dropper like in the schematic. So we'll install the bleeder resistor, balance resistor. I keep using the term interchangeably. Please forgive me. Just use a bit of braid on that one. It's hard to get the solder gun in at the right angle. Got a feeling this is lead-free solder. It's a little bit harder and brittle and crusty compared compared to the leaded stuff. You know what, that's interesting. So the tube amp docked capacitor, same as the one on the chassis here, on the inside, it appeared to have lead-free solder, whereas the snap-in caps had leaded solder. So that adds to the hypothesis that someone's played knifey spoony before. Right, now I've got some lovely stranded... I'm stranded, far from home. Got some stranded Teflon wire here. Doesn't matter how long you heat it for, it doesn't melt the jacket. So that's great because you can rework the thing without making it look like arse. Ooh, burnies. So there you go, Teflon. A little bit harder to strip, but it's worth it because you don't melt the jacket over the years of servicing an amp. Right, so we've got the balance / bleeder resistors on the reservoir caps now. We've got the wire linking them, the Teflon wire. You can see there's a excuse me, a little bit of slack in them. That's, I guess, a little bit of a signature move of mine. I can sort of tell that I've worked on an amp before. I'd rather have a little bit of slack in them than have a really taut wire that's got no give to it. There we go, so the bleeders are all installed. We've got the proper crimped wires there, the Teflon coated wire. And the best part of all, we've got some wiggly wires here to really fuck up the straight wire fanboys on the forums. Alright, now we've got the flyback diodes installed. We've put them on the top eyelet of the, because you know each pin of the octal output sockets has two little holes in the eyelet, so we've put the actual plate connection through the bottom one, and we've put the diode through the top one so they can be replaced if they go short circuit in the future. And we've cleaned up the connections on this chassis mounted cap on the end there as well. Just done 270-degree wraps just through and back over, and removed the old solder and put new stuff on. Alright, so we fired it up, double checked everything. Check the voltage across these caps now. 240. 240 within a volt. That's what we want. That's what those balance / bleed resistors do. Alright, so we'll just have another quick play through it. Most of that scratchiness is gone now. We've cleaned up the leakage on that board. We'll set everything 12 o'clock. Treble down. Treble up and take your head off in the bright channel. Bass up. Bass down. Be interesting to see how it interacts with that Fane speaker that's in the cabinet, because it is a combo. It really does come to life with the master at 12 o'clock or higher. Yeah, it's angry, but now it's happy. So it's happy and angry. Does that make sense? You know what I mean. So anyway, we'll chuck this back on the shelf. I forgot to mention this is actually a shop showroom model that we picked up. So yeah, when I was talking about modifying the triode, I was sort of half joking, but I wouldn't do that to someone's amp without them specifically requesting it. But I think we'll leave this one in the state that it's in as a representation of what these amps are. Well, now that we've sorted out all the fuckery anyway. So I think I'll leave it up there on this one, and we'll just clean up the cab, put it back in, stick it on the shelf, nice and pretty, and move on to the next actual job. We sold a bunch of amps, a couple of amps, and resupply is an issue, so we've got a few empty spots on the shelf, so I thought I'll pull out some of the long-term projects and just get them happy and healthy and stick them on the shelf just to fill those gaps that were when I get around to it projects, but it looks a bit silly having an empty shop, so I thought I'd better get my ass into gear. So thanks for watching, champions. We're going to upgrade the audio stuff soon, so you'll have better sound, better representation of each amp's tone, some close miking, but we're just too busy, man. So bear with me, but you know, it's incremental. As long as we don't go down in quality, as long as it's a gradual uphill thing, I think we're doing the right thing. So stick with me, and you'll be rewarded with more nicer videoage. So anyway, take it easy, champions. See you on the next one. Blah blah blah.